Alright, we're going to continue our chapter on geometry by looking at circles. So we start with some vocabulary, right? Some terms. A lot of these, some of these will be ones we're already familiar with. I think in the first figure here, we get what the center of a circle is. We probably are already aware of the fact that the diameter of a circle is twice the radius. So a diameter is a line that goes from one point on the circle to another point on the circle, but through the center. The radius is just from the center out to any point on the circle itself. These next ones may be unfamiliar to us. A tangent line is a line that just barely touches a circle at one point. If I draw a line that passes all the way through the circle at 2 points, we call that a secant line, or just a secant. And a chord is kind of like a secant line, but it doesn't extend beyond the circle itself, right? So it just sort of stops, right? If I extended the chord longer, it would become a secant. We have some formulas that we can use to find the area and the circumference. The circumference is just the distance all the way around the circle. The circumference is given by 2 pi r, and the area of the circle is given by pi r squared. So here's a quick example to start us off. Let's find the area and circumference of a circle that has a diameter of 3.6 meters. Now the first thing I'm going to do here is just say, okay, they gave me the diameter. That means I can find the radius. And I'm going to find the radius. The radius is half the diameter, so I'm going to take 3.6 meters divided by 2, and I get 1.8 meters. The area, I guess I'll just start with there. We could start wherever we want. I'll pick the area to begin with. So this is pi r squared. That'll be pi times 1.8 meters squared. So if I square 1.8, I get 3.24. So in terms of pi, this is 3.24 pi square meters. There it is as an exact area. And then I can approximate on the calculator and get 10.18 meters approximately. Square meters. For the circumference, use the circumference is 2 pi r, so that's 2 pi times 1.8 meters. So we see that the circumference will have units of just meters, whereas the area had units of square meters, and that's because we were squaring the 1.8 meters, right? That gives us square meters. And that makes sense. Area has squared units. The circumference is just a length, so that has just area, units of just meters to the first. 2 times 1.8 is 3.6, so in terms of, as an exact value, is 3.6 pi meters. And we could approximate this as well. 11.31 approximately. Now you might notice, and maybe this is already another formula you're familiar with, but if you take a look at this part, you could see that really what we have is the diameter times pi. I always think of the circumference as 2 pi r, like in terms of the radius instead of the diameter, but it's equivalent to pi times the diameter. So either of those works for finding the circumference. Now we're going to spend some time talking about arcs and angles. So an arc of a circle is just a piece of the circle, like the curved piece, right? So as sort of illustrated here in this figure on the right side. If I start at, if I take this center point and I draw 2 points out to the circle, like maybe extend it out to point A and then to point B, then what I can form here is a central angle. We call it a central angle because the vertex is at the center. So I have this central angle. And the other thing I form, if I just look at that kind of piece of pie that's cut out there, that it's shaded in blue, we call that a sector. So a sector is very specifically this sort of piece we can cut out by starting at the center and going out to the edges. I could also just cut off a piece of the circle like is shown over here. We call that a segment. So a segment is cut off by using a secant line, and a sector is formed by using two radius measurements from the center out. So an interesting fact, well, before I get to the interesting fact, we've talked about the central angle, right? If I form an arc, then there's a correspondence with an arc to its central angle. But I could also, instead of forming the angle with a vertex at the center, I could take an arc and I could form an angle by using a vertex as any other point on the circle. And that's what we're doing here in this figure on the left. So we call that an inscribed angle. So my vertex is a point on the circle, and I draw lines out to two other points on the circle, A and C. So we call that an inscribed angle, and then this arc it cuts out is called the intercepted arc. Now, any arc also can be associated with a central angle. In fact, the measure of an arc as an angle is equivalent to the measure of the central angle that it's associated with. Fun fact, though, that the inscribed angle is 1/2 of its intercepted arc, meaning it's 1/2 of the central angle. So let's say this is the center, and here's the, if I draw the central angle associated with that intercepted arc, let's say this is like, I don't know, maybe 50 degrees. That means that the inscribed angle would be 25 degrees. And what's even more interesting is that inscribed angle, we get the inscribed angle by making the vertex any point on the circle itself, B. So no matter where I draw that, this figure's about to look a little bit busier, but no matter where I pick that vertex to be, these angles are all 25 degrees because they're going to be 1/2 of the measure of the central angle that's associated with that arc. So let's get some practice using these values here. They tell us that the measure of angle CAB is 30 degrees and the arc AC is 100 degrees. So that's this measurement here, right? From A to C. Sometimes there's some confusion about whether an arc, because if I think about going from A to C, there's two ways to get there, right? Two ways around the circle. But since that arc is only 100 degrees, it's got to be this figure here, and they did label it, so there's no ambiguity. We want to find the arc BC, we want to find the angle ABC, and we want to find the arc AB. So, for the arc BC, that's this guy right here. Now they gave us, we know the intercepted angle, or the inscribed angle, rather. CAB is 30 degrees. That means that the intercepted arc has to be 60 degrees because it's double the inscribed angle. So we know that that is 60 degrees. And let's see, the arc, or angle, ABC, we know the measure of the arc AC here is 100 degrees. And angle ABC is the inscribed angle for that arc. So angle ABC is 1/2 of the intercepted arc. So that's 50 degrees. That will allow us to find, well, I guess that would allow us to find ACB, but they didn't ask us for it because we know how to find it. That's a triangle. So that would have to be 100 degrees. We want the arc AB, and actually I guess that means it's helpful to find the measure of this angle at 100 degrees. We want the arc AB, and the angle ACB is actually the inscribed angle. So the inscribed angle is 1/2 the intercepted arc. So that means that the intercepted arc is going to be double the measure of that angle, or 200 degrees. Another way to get to this being 200 degrees is that altogether we have this circle, right, all the way around, and the total arc of a circle is 360 degrees. We knew already that we had 100 degrees here and 60 degrees there, and that means there are 200 degrees left to make the whole circle. So that arc must be 200 degrees. Here's a special result. So here's a circle. PQ is a diameter. So this point O is O for origin. That's the center of the circle. So PQ is a diameter, which means it has to go through the center. We want to find the measure of the angle right there, PRQ. So since this goes through the center, right, that means that this is actually POQ is a central angle, but it's a straight line, so we know that that's 180 degrees. So this arc, PQ, is 180 degrees, and PRQ is the inscribed angle. So since PQ as an arc is 180 degrees, that means that angle PRQ has to be 1/2 of that. So it's 90 degrees. And so what that means here is that we know that this is, in fact, a right angle. Now, remember that for an inscribed angle, it doesn't matter what point, which exact point in the circle you pick to be the vertex, right? So I could pick this point, and I have the same intercepted arc. I could pick this point and get the same intercepted arc, right? These are all right angles. And so one takeaway from that is that if you inscribe a triangle inside a circle and one of the sides is a diameter, you know it's going to be a right triangle. That inscribed angle has to be 90 degrees.